Hello everyone and welcome to another video. In this video, we are going to do case study question and that's based on chapter real numbers. So let's begin with the first question over here. It says three sets of English, Hindi and mathematics books has to be stacked in such a way that all books are stored in topic wise and height of each book is same. Now it's important to understand height of each book are same and books has to be arranged topic wise. Now, they further say that the number of English books is 96, that of Hindi is 240, and the mathematics is 360. So we have these books numbered as 96, 340, and 336. Now, if I read the question followed, it says you should keep in mind that the thickness of each book, all books are of same thickness that's mentioned. Now, the first part here is the maximum number of books that can be present in each stack. So let's say this is one such book. If I arrange one over the another like this, do not count their numbers. I just want to show you that whatever, since their thickness are same, right, in a single stack, what you can do in a single stacks, the number of books will be same. But we have to maximize this number. We have to maximize this number in each stack. So therefore, whatever is the number, whatever is this number will be same as this, will be same as this. Let's say, for example, I take the first book, mathematics, right? Here 96 is the number of books, right? I'm not talking about the number of books in a stack. Here I'm talking about the total number of books is 96, 240, and 336. Now check here. Since we need equal number of books in each stack, whatever be the number of books is present here must be the exact divisor of this. That means whatever is this number over here must divide 96, 240 and 336 exact number of times. That is what the question. And any number which can divide these three exact number of times has to be what? The HCF, right? So this is what we are going to do is to find the HCF for the first part. Here we are talking about the first part over here. So we will be finding the HCF of these three numbers. So for that, we are going to apply prime factorization method. Well, there are. If you find the prime factorization, as I said, we are going to do by the method of prime factorization. So this is what we will get after prime factorization. We get these. Now, to find out the HCF, what we are going to do here is to first, if I write 96 as a power of 2 and 3, this is how many times? 2, 1, 2, 3, 4, 5, 2 raised to the power 5 and 3 raised to the power 1. For 240, we are going to get 2 raised to the power how much? 4 multiplied by 3 and 5 raised to the power 1. And similarly for 336, we are going to get this as 2 raised to the power, this is how much? 4 multiplied by 3 into 7. Now for finding the HCF, what we do? We look for the one which, like say for example, if I look for the 2's here, 2 with the common factor as 4, right? 2 raised to the power 4 is common. So we are getting the HCF here, which is 2 raised to the power 4. For 3, you can see it has 1, 3 as common, but then 5 and 7 are not common throughout. So this is 2 raised to the power 4 is how much? That's 16 into 3. So that comes out to be 48. Yes, we have an option here. 48 is the correct answer for this by finding. So we'll say that the maximum number of books that can be put in a single stack of each book, right, will be 48 in numbers. Now let's move to the next part. We can do it over here only. Now coming to the next part, what they say that in the, say if I make some space over here, this is the number of each stacks of English books. So how many English books are there? If you see, the number of English book is 96. So 96 books are there and in a single stack there are 48 books. So can we say that the number of stacks of English book will be 96 divided by 48. One more time, we have total of 96 books, and in a one stack we are keeping how many? 48 books. So number of stacks will be 96 over 48, that is 2. So we have an answer over here, option over here. 2 is the correct answer for the this part. Now, similarly, we can do the other parts also. It says the number of stacks of English book. No, sorry, mathematics. This time it is mathematics. And how many mathematics books were there? 36 in, sorry, 336 in number, right? It was 336 in number. So if I say the same way, if there are 336 books of mathematics and a single stack have 48 books, so clearly we can find the number of stacks for what is that? In mathematics book will be 336 divided by 48 should come as 7. So yes, we have an option over here. 7 is the correct answer. Now we are going to do the other parts over here. Let's say if I see the same way, it's all same, the number of stacks of Hindi, and how many Hindi books are there? They are 240 in number. So needless to say, the number of stacks will be 240 divided by 48. That's reduced by 5 times, right? So we got this as 5. Now the later part is, the last part in fact, it says, which of the following concept was used in finding the maximum number of books? Well, this should have been asked in the beginning because we have already done HCF, right? So everybody can answer this part. Now let's move to the next question. Now this is a case study, question number 2. From the same chapter, real numbers only. Now if I read the question, it says HCF and LCM are widely used in number systems, especially in real numbers, in finding the relationship between different numbers and their general forms. Also, product of two positive integers is equal to their LCM and LCF. So in the first part, it says if two positive integers x and y are expressible in terms of primes as x is equal to this and y is equal to this, then which of the following is true? So let's understand this. First, we have given x and y as two integers, and the prime factorization of x is this, and for y is this. Now, what we have to find out is which of these relations are correct. So clearly, we need to find the LCM and HCF before determining which of these options are correct. So I'll go by first, say LCM. Now, what is LCM in this case for these two numbers? What you can see that we take the highest power of each prime. So P has P square here and is P cube over here. So it is P raised to the power 3 in this case. Now likewise, if I go for the other, Q has a highest power as 3 and Q has a highest power as 1. So we'll say that Q with highest power 3. So this is what we got as the LCM. Now, for finding the HCF, we look for the highest common factor. That means it has to be common. So from P square and P cube, what is common? What is common? P square is common. And likewise, if I say between Q cube and Q, what is common? 1Q is common. Now, we can see the options and decide which of them is correct. It says HCF can be obtained as multiplying PQ squared with LCM. So if I multiply, let's say if I multiply PQ squared to the LCM, are we getting this? Clearly not. So first option is not correct. If I read the second one, it says that LCM can be obtained by multiplying PQ square with HCF. So this is HCF. This is our HCF. Now if I multiply PQ square, right, this is our HCF. Multiplying PQ square with the HCF, it becomes P square into P, that is P cube, and Q into Q square, Q cube. Yes, it is correct. So we'll say that the option B, yeah, that's option B. Yeah. B is correct. This is the correct answer. Now let's come to the next question. In the third part, it says find the largest possible positive integer that will divide these three numbers, leaving remainder 7, 11, and 15. That means we have to look for the largest possible integer which will divide this leaving 7 remainder, this leaving 11 remainder, and this leaving 15 remainder. So what we can do as of now, we can ignore this part. Let's ignore this part of leaving remainder. Just look into this part, which will be the largest number or largest possible integer that will divide this exact number of times, right? So any number that will divide these three number exact number of times has to be the greatest common divisor, greatest common divisor, which is same as HCF. That means one thing is clear, that this is a question of finding the LCM, sorry, HCF, right? Highest common factor. But HCF will leave zero remainder, right? HCF will leave zero remainder, but in this case, it is leaving remainder. So that means if I remove this remainder from this, then it will leave zero remainder. One more time. That means from the number 398, if I remove 7, that means if I subtract 7, that is 391. Similarly, from 436, if I subtract 11, it's going to be what? 425. And from 542, if I subtract 15, right? So 12 minus 5 is 7, and this is 3 minus 1 is 2, and 5. So instead of finding the HCF of these numbers, we should find the HCF of these number. Why? Because if these three numbers are leaving remainder this, and we know that HCF leaves zero remainder. That's the reason. And for finding the HCF of these three numbers, we are going to use the prime factorization method. So let's do the prime factorization for these three. So on prime factorization, what do we get? We can see from here that I've already done here that 17 is the only common factor, right? And therefore it has to be the highest common factor. So the correct answer will be 17. Yes, we have an option. Option D is correct in this case. In the third part, it says find the least positive integer which on adding 1 is exactly divisible by what are these two numbers? 126 and 600. Well, like the previous one question, ignore this. Ignore adding 1 over here and just read it once again. What is the least positive number, least positive integer, which is exactly divisible by these two? Since a number is exactly divisible by these two, has to be the common multiple of both of them, right? And we are looking for the least such number, so it should be least common multiple, that is LCM. So first thing that we will do is to find out the LCM of these two numbers. So we are going to find the LCM, and then we will be looking into this part of adding 1. So we are going to use prime factorization over here for finding the LCM, and the prime factorization of these two numbers is here. Now, if I ask you what is the LCM, then for finding the LCM, what you are going to do here, 2 with the maximum power is how much? Throughout, right? 2 with the maximum power 3. So this is 2 raised to the power 3. And next is what? 3 with the maximum power 2 over here. So that is 3 raised to the power 2. And similarly 5 with the maximum power 2 again. So this is 5 raised to the power 2. And then we have 1, 7 over here. So the LCM will be the product of these numbers, right? So if I find its product, this is 8 into 9 into 25 into 7. This is how much? 72 into Should I do this? No, later. 25 into 7. So 1/4 of 72 will be how much? 36, 18. So this is 1800 into 7. So we can say 18 into 7 is what? 126. So it should be 126 followed by two zeros. But then this is the LCM, right? This is not our final answer. Now read it again. It says find the least positive integer which on adding 1 is exactly divisible. We know that this is exactly divisible, but we are looking for a number which on adding 1 will be exactly divisible. One more time, we are looking for a number which on adding 1, so like say x is such number, for example, x is such number, on adding 1 should be exactly divisible. And exactly divisible is the LCM. So can I say that our required number will be x plus 1, like x we are looking for, x plus 1 is equal to 12600. So clearly x will be 1 less than this, which is what? 12599. Yes, it should be. So this is B part is the correct answer in this case.